Welcome to Classic 9.1, textbook section 6.6. Today we're going to be discussing vectors. So first start by just writing vectors on your paper, like that, vectors. And a vector is basically a directed line segment. So I have 2 points here, P and Q. I'm going to call P my initial point, and then Q is going to be my terminal point. It's important to know that it's a segment, meaning that it's going to start at P, it's going to head towards Q, and it actually stops at Q. It does not keep going. Now, the length of this vector is referred to as the magnitude. So you might remember from a class, maybe in science, that a director has two pieces. It has magnitude and direction. Okay, so again, each vector has this magnitude, direction, which means there are four relationships that could occur. Number one is right here. This would be same direction, same magnitude. This is number two, same magnitude, different direction. Three is kind of weird. It's the same magnitude, and we actually specify when it's the opposite direction. So that's a different category from just a different direction. And then number four is going to be different magnitude, but same direction. Okay, so those are the four relationships that can occur between two vectors. So let's try it. Sketch the vector negative 3i plus 4j. Okay, so to do this, the first thing to note is we're going to fix the origin as the initial point. You don't have to do this, but it does make it easier. So I'm just going to put a dot right there at the origin. The next thing to know is notation. So most people use V and then they put like this little hat here or this arrow. And that's going to be AI plus BJ. This is called your X component. And this is called your Y component. And it functions exactly like you would think. Negative 3i plus 4j just means go 3 left and 4 up. So here's the terminal point. And then we're going to connect them with the arrow. And it goes right there. And this is going to be a vector V. Now to denote magnitude, with vectors we actually put 2 bars like this. So this would mean find the magnitude of vector V. And the way you do that is exactly what you think. Let's do the Pythagorean theorem. So the root of a squared plus b squared. So in this case, for this one, the magnitude of that vector would just be the root of 3 squared plus 4 squared, which is the root of 25, which is 5. Okay, here's the next one. So now it says let V be the vector from the initial point 3, negative 1. So in this case, it's giving you a point 3, negative 1. The terminal point negative 2, 5. Okay, so I'm going to plot 3, negative 1 right there. And then negative 2, 5 is right here. So I'm just going to start by drawing the vector. So here's our vector right there. It says write this vector V in terms of I and j, which essentially means we're trying to make it into, we're going to call this like component form. So if I were to box this right here, this is like a form we're working with. So we're trying to get it to this form. So we have 2 points. All we're going to do is subtract them. So think of it as if the terminal point is the endpoint, we're just going to do the terminal point minus the initial point. Or some people say like x2 minus x1 I minus, or sorry, plus y2 minus y1 j. So it kind of looks like slope, but essentially we're just gonna subtract them. So my x2 point is negative 2, so negative 2 minus 3i, and then 5 minus negative 1j. So now I have negative 5i plus 6j, and that's going to be my vector in component form right there. And notice how, if you want to analyze it, you can see that this is going 5 in that direction and 6 in the vertical direction. And that's all this is saying. You're just breaking up your vector into components. In this next example, we're going to talk about how to add and subtract vectors. And at first glance, it's pretty easy. You just have to add the components together. So for example, for A, 6 plus 5 makes 11i. 4 plus negative 9 makes negative 5j. There's your answer. And for v minus w, 5 minus 6 would make negative I. 4 minus negative 9 would make 13. So negative I plus 13j. Now you have to understand what's actually happening. So I have a picture down here. I'm going to put it together for you. So 5i plus 4j, that would be right about here. So there's vector v. And vector w, 6 minus 9j, that would be right about here. So there's w. When you add vectors, what happens is it grabs the tail of w and connects it to the head of v. So there we have it. And what we're going to do now is connect the beginning of v, the initial, to the new terminal, the end of w. Notice how it makes a triangle. This is the vector v plus w. And you'll notice it looks a lot like the thing we found when we added. If you look at this closely, you'll notice that this thing is about here, going out 11, and it goes down about 5 units, which means it's 11i minus 5j. And look, that is the vector we found. So in a nutshell, your summary is going to be right here. The vector v plus w is the tail of w connects to the head of v. And for b, you're probably wondering, well, how does that connect? You think of this like vector v plus the negation of vector w. So essentially, you flip w, and then you connect that, you connect the flip version of w to vector v. So our next example is going to be scalar multiplication. So for scalar multiplication, again, it's pretty intuitive. Just do 6 times vector v, so 6 times 5i plus 4j. That would be 30i plus 24j. And for b, just multiply by negative 3, so negative 15i minus 12j. So mechanically, again, very easy. Now to understand it, this is what's happening. Look at the picture below. Here's vector v about here. And now vector 6v basically takes the same direction and extends it like this. Right about, let's say here. So not perfect picture, but you get the idea. Same exact direction, just longer magnitude. So for our next example, we're going to be finding a unit vector. So everyone just highlight this right here, unit vector. Put simply, a unit vector is simply a vector with magnitude of 1, with magnitude equal to 1. And the formula is really, really simple. Unit vector. You just take your vector and divide it by the magnitude of that same vector. Okay, so box that. You're going to need that for today. So let's try it. Let's take the vector, 5i minus 12j, and divide it by the magnitude. Now some of you could probably do that in your head. If not, just write it out. The root of 5 squared plus 12 squared, that's the root of 169, 13. And now we have it. The unit vector is 5 over 13i minus 12 over 13j. So that would be the vector in the exact same direction. So if I were to sketch this, our vector 5 minus 12j would be somewhere over here. The unit vector is going to be in the exact same direction, just a little piece like that, and the length is 1. So that's our unit vector, and again, the length is simply 1 unit. Okay, last example. The wind is blowing at 20 miles per hour in the direction north 30 degrees west. So this is a bearing problem. You might recall this from trigonometry or Algebra 2. So all you need is to draw a quick axis, north, west, south, east, and you're going to draw a vector 30 degrees to the west of north. So that's all that means. North 30 degrees west means from the north, turn 30 degrees to the west. This vector, we can call it V, is the wind. And it says 20 miles per hour, which means instead of V, maybe it would be better to call this 20, because that's a concrete number. It says express that vector V in terms of I and j. So all we need to do is figure out what is this x component, what is this y component. Now that should look pretty familiar because that's just like our last test. That's polar. Let's call this x, let's call this y. This rotation is 120 since we know quadrant 1 is 90. And recall our polar pieces, right? X is equal to r cosine theta, y is r sine theta. R here is 20, cosine 120, y is equal to 20 sine 120. So we do our trig, that would be 20 times negative 1/2, x is negative 10, y is 20 times root 3 over 2, so y is 10 root 3, and there we have it. Our vector is negative 10i plus 10 root 3j.